As always, a big warm welcome everybody to How to Repair Pendulum Clocks, our 22nd, I think it is, Open Clock Club. So we're approaching the halfway mark, which is kind of quite scary, really. Anyway, I hope you've had a great week and a great horological week as well. If you've been following us on Facebook, you will know, and LinkedIn, you will know it's been a busy old week for us. We've been on contract, doing a bit of work, and also doing our live stream, of course, on Thursday, which was cool. We made spring, a ratchet click spring for a long case clock. And so the whole place is in disarray, as always, because of all these great projects that's going on. In fact, that's going to be a bit of a theme for this evening, because I want to get one of our clocks actually put back together again, which is quite a rare thing. So extra special welcome to anybody who's new here for the first time and for beginners. And that beginner theme is going to get us started. And but before we get started, 2 points. As always, remember these sessions are recorded and they appear on our archive YouTube channel. So if you wish to remain anonymous, then please keep your camera turned off. And the second and really important point is that me sat here talking, trying to answer your questions best I can, is only half of what we're about. We're about a community of people who are interested in repairing pendulum clocks. So we want to know where you are, what you've been up to. So please, in the live chat, have a talk with our Open Clock Club team, and we'd be delighted to say hello and many other things. So as always, we've got 2 or 3 things going on here. We're going to actually, I think for a few weeks now, we've probably pretty much neglected our beginners, and this is meant to be a sort of beginners channel and to support people who've bought our book. You can see up here with fairy lights. So thank you. We've another few have gone out the door, which is brilliant. And so we're going to actually reassemble single train Enfield. It was the one, if you remember, for those people who were here a few weeks ago, where we repivoted the pinion end of the upper intermediate wheel, also known as the third wheel to some people. Anyway, so I think it's about time we got that clock back together, because we've used it for demonstrating the escapement, for doing that repivoting. And then, of course, we started that and then realized that the mainspring hooking was cracked. So all this incredible stuff is on the archive. Unfortunately, we don't have an index to that archive yet. Maybe one day we will, which would help people search it, but it's all there nonetheless. Speaking of archives, a couple of weeks ago, we had our first ICON, that's the Institute of Conservation Dynamic Objects network meeting, which was great. We had 10, no, we didn't, we had 6 10-minute talks. So big thank you to Chris out there. Hi, Chris, if you're there, for editing that film. And just to let you know that it's just gone up on the ICON YouTube channel. We'll put a link in the description of this video if anybody wants to catch up with that. There's some quite interesting stuff going on there. And the next one of those is on the 10th of May, same time, 6 o'clock in the evening, British summertime. Okay, so beginners, without banging on about the book, because that's not the point of these sessions, but John and I, John's here this evening, spent a long time figuring out what we felt, and of course there are many ways to skin a cat, as the saying goes, we felt was to get people started in repairing pendulum clocks. So the Smith Enfield single train or something similar isn't, of course, the most challenging clock to repair, and it's probably not really that representative of what people repair, because normally people repair clocks with 2 trains, which is our second book. And so as much as everything else you might learn in that book, the point of the process was to actually get a clock that most people with a relatively modest range of tools could buy a clock for a relatively modest fee as well. Take it apart, clean it, put it back together with some adjustments made for the beginner, like maybe leaving the mainspring in the barrel and things like that, and not to say I'm a clockmaker, but to kind of get that ring of confidence that it can be done. And I think what I've seen over the past few weeks on Facebook and elsewhere are people, understandably, we've all done it, but getting in too deep to a project and then running into all sorts of problems. So that's just a bit of sort of background on why we chose this particular clock, confidence building exercise. So my advice to you is not to buy the book per se, but if you've gotten into that situation where you've gotten in too deep with a project, put that to one side, get a clock like this, work through it, you'll learn a lot, and you'll have a ticking clock on the mantelpiece, which is a really useful thing. So slightly related to that, we've had a couple of re-pivoting jobs that have caused people problems over the past couple of weeks as well. And we've all been there with that. These clocks, as you saw a few weeks ago on this channel, are kind of like everything, kind of quite tricky to, everything's tricky to re-pivot. And for the beginners, what I mean by that, just move that out of the way, is we've got a clock wheel, what we call a clock wheel here. The clock wheel runs on an axle, which is called the arbor. And you can see at the end of the arbor, there are two reduced diameters. They're 1/2 of a plain bearing. They're called the pivots. And for whatever reason, it can be rough handling, it can be because of a broken mainspring, it can be because somebody took the clock frame apart accidentally without letting the power off first. But the pivots can get broken or bent. Now, we had a bent one on this clock. I tried to straighten it, it broke off, so we had to drill it out. And the reason, again, why we start with a clock like this is the material here, the steel, is quite soft, so it's relatively easy to drill. Whereas if you begin on something like a French clock, you know, one of those pendules, not only are the arbors quite small, but they're left very hard by the maker. So they're kind of quite difficult to drill. So a bit of advice for if you're trying to drill out an arbor, ideally you would hold the wheel in the lathe, so it's spinning. If you didn't see it, it's maybe worth looking back a couple of weeks ago to when I drilled this out, because I use a lathe that's operated by hand, which may seem a bit archaic, but the beauty of it is it allows you control. If you've got a lathe with a motor that doesn't have variable speed, then you're going to run into trouble when, not trouble, problems, challenges when you do this kind of work, because your drill will immediately blunt and it'll work hard in the hole. And we've seen this recently, so hopefully this will be help. How do you get out of that? Well, if you're drilling with, let's just find one. If you're drilling with something like this, which is a kind of regular, what they call a jobber drill or a twist drill, you've already got a bit of a challenge, because these drills are a sort of universal sort of panacea, if you like, for all things DIY, you name it, it does that job. And of course, like everything universal, as my old mum would have said, they don't really do anything particularly well. They don't drill particularly round holes, they're not to size, etc., etc. But of course, we all use them, they're absolutely invaluable. For drilling out an arbor, you want a slightly different thing, really. And on the YouTube channel, other YouTube channel, I'll show you how to make a pivot drill. You can buy them, I think, both in steel like this, and you can buy them in tungsten carbide. Now, tungsten carbide is incredibly hard material, much harder than this steel and abrasion resistant, but you don't get out for now, as they say in York, and they're very fragile. They break up easily, and if they break up in the hole, then you've got yet an even bigger problem to try and resolve. So if you want to get started with a drill like this, and I'll just give you a couple of tips to begin with. If I can just find my paper. Thank you. So when you look down on the end of a drill, it looks very broadly something like that. And I don't know if I got that right or not. It might have a tip, or it might have a split tip here with this bit offset. Now, of course, the manufacturer of these drills is trying to meet a compromise, like this whole universal thing. So they're trying to make the drill cut well, but they're also trying to make it strong. So you can go down the DIY shop, buy a drill a hole in a bit of plastic, and it doesn't break off in the hole. So this value here, which I think is called the web, so we're talking about that value, web even, is quite thick. It's too thick for what we want, because this part in the middle isn't going to do any drilling. It's just basically going to squidge up against the end of the hole. And so what tends to happen, and again, it doesn't matter if you're drilling a bit of wood in a kind of DIY situation, but you tend to start pushing harder, which either breaks the drill or blunts it, or work hardens the hole. So either make a drill or thin this down. And you can do this very easily. And so this is a bit of a compromise. The thinner the web is, the quicker it's going to drill, but the more likely it is to break off. So what you might do, and it may be easier to demonstrate this, but I think we've shown this before, so I won't go on about it too much. But if that's the drill there, you can make the drill sharper as well, as in this angle here, you can increase that. And again, it's the same thing, that will drill more readily and probably keep centered a bit better than one that's got a wider angle like a commercial drill. But of course, it's going to go blunter quicker as well. So the way you get round it not blunting super quickly is to drill dead slow. And when I say dead slow, that's why I use that hand wheel, and partly because I don't want to pay for the electricity, of course. And I mean dead slow. Don't drill fast. If you're trying to drill with an electric drill or a Dremel or something like that, you're really causing yourself a major, major problem. On the live stream we did on Thursday, again, because I don't have a drill press, I was using an Archimedean drill, a little sort of, find one here, manual drill like this. Put it under here so you can see it. And you might think it looks like a bit of a joke, but it's incredibly useful because you've got control over the speed and the amount of pressure that you apply to the drilling. So if you don't want to go down the route of making your own drill or buying a spade drill from a kind of commercial supplier, I think in England there's a company called Eternal Tools, ETERNAL Tools, and they sell, I think, carbide spade drills, which are probably really good. If you don't want to go down that route, you can actually kind of turn your blunted twist drill into something a heck of a lot more useful, and just do it by either on a diamond lap thing, and you will be quite familiar now because they're my sort of, not exactly most hated, but love them or loathe them diamond laps. You can either use something like this and just place the drill on the lap. Let's just go in a bit closer. Place the drill on the lap, and if you just rotate it, you can feel the point. You can feel the, not the point, the stage where the two sharp edges meet. So if you just rock it like that, what's useful to do at that point is just to put a bit of a mark on here and flip it over 180 degrees and do the same on the other side. We will need those marks later. And just tip the drill up from that position, just find it again, and stone it, or use the diamond lap or whatever, keep turning it over, and continue looking through your eyeglass or your microscope or whatever you use until the web of the drill is significantly thinner than it is when you buy these little twist drills. I'll just check with Team Open Clock Club. How's the live chat going? Yeah. So don't throw these drills away. You might think that they're dead frustrating, which they are, but you can always make something out of it. What you can also do, while I'm just sharpening this, and I probably won't get that far, is harden them harder. So from the manufacturer, again, you remember that manufacturer is trying to make a compromise between the drill breaking and it actually doing a job. And, you know, most people in the DIY sort of shop environment might drill a bit of wood, they might drill a bit of aluminium, they might drill a bit of plastic, but they're quite unlikely to drill a bit of hardened steel as we do. So the manufacturer dials that in so the drills don't break. And so what I would say was you can heat the tip of this until it glows bright orange and then quench immediately, and I mean immediately, so straight from that orange stage into cold water to harden the tip of the drill more than it would be when you buy it. And of course, again, by doing that, what you're doing is you are increasing the risk of it breaking off. But if you've got the situation where you've got a particularly difficult thing to drill, that might just get you started. And then lubricate the drill with spit is the best thing, as we said a few weeks ago. If you've got, I'll say it again, if you've got a hog tethered in the backyard, as everybody in Yorkshire has, then the drool from a hog is definitely the best kind of spit for lubricating your drill. Otherwise, a bit of wintergreen oil. When we I went with the students on a tour. We went to Germany, and they were really fascinating there, because doing a lot of engine turning, and they lubricated the engine turning bit with wintergreen oil, which I think is a bit like turpentine spirit. So it's a kind of natural oil from pine trees, I think. And that was also really nice and a bit less gross than using hog spit. So anyway, you can see the point, as it were, with the drill here. I don't know how far I'm getting. Yeah, you probably won't be able to see here, but it's reduced the web by about 1/3, so the thickness of it. So I'd have to keep going. I would actually put some lubricant, a bit of water on the ceramic stone. I use the diamond. And as I say, the thinner you dare make that, and especially if you re-harden it, you are going to cut, at least at the beginning, much better. And then to sharpen, when I made the drill in that video, I used a pin vise with a square collet, so you can kind of turn it around 180 degrees. Here I don't have that, but what we've got are our little marks. So put the just put a bit of water on there. So put the drill upright and then tip it across to get one angle, and then tip it backwards to get on the basis that the drill is drilling clockwise, to get the relief angle for actually cutting, and then a few strokes away from the cutting edge will resharpen that drill. So nice little job for the weekend. If you're not working tomorrow, then you can get all those old twist drills and you can resharpen them. Now, inevitably, you won't, doing this by hand, you won't get the center exactly in the center, but you can look through under a microscope or through your eyeglass and get it something like. Remember, in clockmaking, we normally drill under size anyway and then broach to size. And with our pivot, it doesn't really matter because we're going to make the pivot to fit the hole. So, yeah, still, even though I've been messing about with this drill for a few minutes now, it's got quite a long way to go before it's thin enough to actually drill properly. Because once that end bit is blunted, you have had it. Anyway, hope that's of help. And I think the most important thing here, which is, you know, why we run these events and why we've got our Facebook group, is that you are not alone. We've all been sat there at the lathe or in a workshop with something that's either broken, you can't remember how to fit it back together again, or something's gone wrong. You're not alone in that. So please get in touch. And as you know, we've got some really cool, experienced people on the Facebook group who are always really happy to help. So big shout out to you people on the Facebook group who chip in there with the answers, and also share your tools and clocks and pendulum clock repairing techniques. So there you go. If you've got blunt drills, don't chuck them out. You can restore them, whatever that means. Okay, so back to our Enfield. Yeah, and I think it was last week we gotten talking about oil. Now, I don't know anything about oil, so I'm obviously not going to get started banging on about it. But all I can say is what we say in our book, if I haven't mentioned that already tonight about 10 times, is that we use the Mobius D series lubricant. And I know some people out there, and I've seen on other fora, which is part of the reason why I don't go there anymore, is people say you need to use this, you need to use that, don't use this, use donkey spit, use car engine oil, which sounds really grim to me, but I don't know anything about oil. So what I do is use Mobius D series. We've used it for about 25 years now, not the same bottle. And it seems fine. It doesn't seem to cause corrosion around the pivot hole, and hopefully you're disassembling and washing the clock on a relatively regular basis. Anyway, however, there are Mobius fully synthetic lubricants, and I remember again one of my students recommended the brand Dr. Tilvish, which I think is TILLWICH. And looking at their website this week, I'm going to try and get hold of some of their oil, because they actually I need to turn off my beeping computer. At least they actually say that they're making these lubricants for steel arbors running in brass bearings. And as I've said before, I think the Mobius stuff is great, but it's basically driven by the watch industry. Mobius, I think, is even owned by the Swatch Group, which owns lots of high quality watch houses, brands. And inevitably, that's where their interest is going to be. But the usual thing with all these questions about cleaning, about ultrasonic tanks, about lubrication, is that we need the horological institutions, and you know who you are out there, to spend some money, get some funding, and work with university research departments to actually nail this stuff down. Because I can say what I think, and a million other people can say what they think on fora, but it doesn't really get us much further. Anyway, I'll tell you what we do, and it's in the book. Got a question? All right, okay. Yeah, no, I'm referring to the D5. I think there's D1 through D5. So these are, as far as I understand it from the Mobius website, they are a mix of natural and mineral oil. And as you see, they've got, I just bought these. So these have got, can't even do the math of that, about 3-year shelf life. So presumably that's also the kind of, you know, the period at which you would think about washing the clock as well. If it hasn't, you can see I put the date on where I bought it there. So no, there's a Mobius a series of natural oils. I think they've got white, green, and yellow caps. I haven't bought those for a long time. And I think if we ever do manage that research project, come on, guys out there, somebody must know a tribologist in a university department who wants to take this on. There's your challenge. Those natural oils, actually, I think, I don't know anything about it, are quite good lubricants, but of course they don't last very long. And I think that's maybe a good thing, you know, with more historic clocks, so 18th, 19th century stuff, maybe, I've said this before, I won't bang on about it, the oil thickening and going gloopy and stopping the clock is a good thing because it forces you to take the clock apart and wash it. Whereas that's why I'm slightly cynical about using fully synthetic oils on older clocks, is that the oil will go on longer, it'll run longer, it won't thicken in the same way, but it's been contaminated, of course, unlike in a watch. A clock normally isn't a sealed environment. You've got all those convection currents and inorganic stuff in the air that's landing in the oil. So this, I think, is a good compromise. It's about £30, I think, a bottle here for 5 ml. Is that 5 ml? 20 ml even. And basically, I only use about a half, if that, before it gets chucked away at the end of the expiry date. So use those two, and I think I'll just show you this if I can find it. Yeah, on the live stream, I was talking about this for some reason. So I used this this week earlier on an automaton where there's a really kind of high pressure point. This is used in things like chronograph pushers in watches where you've got really difficult kind of friction environments. I wouldn't use this on a mainspring. I'm going to use a molybdenum disulfide grease on our mainspring. And so lots to learn about oil. The Mobius website is really good. It's full of information. It's got these kind of spider diagrams, but that's probably exhausted everything I know about oil. Great. So yeah, I'm going on the clock. Are the Smiths Enfield? Let's just let somebody in. On the Smiths Enfield clock, as in the book, I'm going to use the D5 on the lower end of the bearings and D3 on the upper end of the bearings. The D5 also on the pallet faces. So the only difference, the difference as far as I can see between these is viscosity. So the higher viscosity lubricant keeps apart those higher loaded bearing surfaces. But of course, it also takes energy out of the system because it's gloopy, it's viscous. The oil that's less viscous for the upper end of the train can't stand the same pressures, as it were, but it doesn't matter because there's less pressure on the mobile. So I use this on barrel arbors. You'll see in a minute, in fact, if I stop talking and start working, barrel arbors, center wheel maybe, and then third wheel or upper intermediate wheel, as we like to call it nowadays, escape wheel pivots and pallet arbor pivots. There are others in this range, but I've just basically ended up using these two. So I'm going to decant, never dip into your bottle, always decant a little bit, otherwise the stuff in the bottle gets contaminated. I'm going to decant, but before I do that, I'm going to get the spring back in the barrel. So I'm going to put my gloves on. I would normally say this every week, normally wear gloves the whole time, but because of the camera and moving things around, it's just not really practical. So there's our barrel. It's cleaned out, but you can see in the corner there, look, a couple of gritty cobs. The corn, the maize husk that we use to dry off the solvent. And interestingly, I was looking at, and some of you will roll your eyes, the top 10 tips to avoid, I know you're going to want to see this document now, the death of your business, basically, and ruination of your reputation. One of those things we dealt with last week, and that's the alignment of the backcock slot with the crutch slot so the pendulum doesn't wobble. So we ticked one of those off, and I can see another one here is gritty cobs in wheel teeth. So we need to make sure that they're all out of the way. So let's take our mainspring, a barrel arbor cap, and barrel arbor. Of course, the paranoia here is that the clock's been apart so long that we lost half the parts. But anyway, I'm going to very quickly just put some gloves on, get those gritty cobs out, then try and get this clock put together, although I don't know what the time is. I was talking too much. Okay, maybe we won't get the thing actually put together today. So I've washed this clock, as we talked about in the book. Don't need to go over that. You can see here these barrel arbor pivots. I'm not a fan at all of polishing pivots when the damage is going in the direction of rotation. I think this is mostly caused by lack of lubrication and contaminated lubrication. So unless there's anything particularly bad there, I'm pretty happy to leave that, because of course if you polish the pivots down, you can see these weren't polished from new anyway, but you reduce the diameter of the mobile, of the arbor, and therefore you increase the center distance of the two mobiles, and you're heading towards maybe having to do bushing, which is more intervention or more damage, depending on how you look at that. So desperately looking around for my puffer, which I saw only seconds before we went live on air, so we might have to live without that. Let's just get those gritty cobs off. Good old conservation brush here by Omega, with a taped or string ferrule in this case to prevent scratching for metal components. So really useful thing. If you live in London, lucky old you can go down to Corneliuson's, the artist suppliers, and see a whole range of those wonderful brushes down there. Got another question. All right, okay. Yeah, question is that the height of the hooking of the arbor here looks significant. Is it a problem if it digs into or it distorts the next coil of the spring? It's a good question, but there's nothing I can do about it. This thing is made on a machine, and actually looking at it, just check it isn't cracked. Doesn't look amazing, but anyway. So the point is that if you look at it this direction, the hooking is more than one spring thickness. So it's going to form, absolutely right, it's going to form a lump in the spring. And if I were making a new clock, obviously, or if this was broken or you were replacing the arbor, then you would reduce the height of that hooking. If I can find the spring. I'll try and demonstrate that. Whoever said that, that's a really good point. So thank you very much. Sorry? Dave L. Thank you, Dave. So I can't probably actually get this hook on here. So the point is that the hooking is, I mean, it has to be more than one spring thickness to hook onto the spring, otherwise it's going to be hanging right on the edge. On things like marine chronometers or watches, they get round this by actually relieving the arbor. So yeah, as this goes round, there will be inevitably a little lump there, but unless there's, for me, as a broadly kind of conservation-based thing, there's a massive amount of evidence here, both in the finish of these pivots and things like that, where yeah, if you were starting from new, you were new making, then you would probably not do it like that, but I am happy to live with it. It's just as it was, but really good point, so thank you for that. Let's just check. We've got all those gritty cobs out of our barrel teeth, and I'm just going to pop the spring back in the barrel. If you weren't here, was it last week or the week before? I can't remember now, time flies. I rather reluctantly re-holed the end of this spring, and we did a little trick where we, you see there in the light, domed up the end so it catches neatly on that barrel arbor, because sometimes the arbor hooking is quite low, which is not a bad idea. So let's get that in there. I don't want grease to fly everywhere. So I'm going to use liquid spray grease here. I don't have any affiliation with this grease. Used it for about 15 years now. I think it's really good for the job. It's quite thin, and somebody on the Facebook group mentioned springs kind of clunking, so there's this stiction, I suppose it is, so you get this stick slip situation, which can be quite noisy, and it obviously will affect the rate of the clock because of escapement error as well for a anchor recoil escapement clock. If you fitted a new spring, and I would avoid fitting new springs like the plague if you can, because that introduces a whole lot of other problems. Leave old springs in if you can, if you think that they're kind of the right strength for the clock. But anyway, new springs sometimes are very finely finished and ground, so it's worth going over them to start with a really coarse grade of something like silicon carbide paper to actually key the surface, which allows oil to stay between the leaves of the spring or the leaf of the spring. If you've been a pedant, because I know John's there and he likes these things to be right. But of course, you have to wash the spring really thoroughly after you've done that. Anyway, so I'm using, like in our book, nearly run out, our liquid spray molybdenum disulfide grease. Again, if anybody need a tiny weeny bit, if anybody wants to do some research on this stuff, then bring it on, because the horological world desperately needs, in my view, to move away from he says, she says, and towards some actual peer-reviewed and published research. Yeah, on a new spring, Jeremy. I do on one day, if it's for a special birthday treat, I'll get the abrasive paper out. I've got loads of it. I've got, when, as I think I probably said before, when that 3M stuff came out about 25 years ago, the polyester backing, I kind of like went bonkers and bought every type they had, and most of it's still there. I love abrasive paper, but never on old clocks. That's the thing. It's like adjustable spanners. The other day we were, I can't remember what we're doing, but it was on the live stream, I think, talking about adjustable spanners. Never ever use an adjustable spanner, as that famous poem goes. And somebody said, well, why have you got so many? Because I love them, just don't ever use them. Well, not when anybody's watching anyway. So we'll move across to fairly sure that's gonna be able to get my hand in there. So of course, mainsprings, always safety. Put my schoolroom safety goggles on, and my so endless controversy about fitting mainsprings. As you may know, if you bought our book, thank you. We use this so-called traditional mainspring winder, which I must agree is not the safest way of doing it. I don't like many aspects of the Ollie Baker type mainspring winder, but it's a lot safer with the concentric rings that hold the spring. So if I were beginning, that would be the way I would go. If you can't afford the version one or don't want to spend $1,000 on it or whatever it costs. So the last thing I need to find is my super pliers. Why don't do what by hand? Or fit the mainspring. Why not fit the mainspring by hand? It's just really dangerous, and I'm not particularly bothered about the distortion of the spring. I think that's all over egged. But what I would say is, if you don't have a mainspring winder, and for a beginner, don't take the mainspring out of the barrel. I've done a video on YouTube, which I'm proud to say has now had 10,000 views, probably all for the wrong reason. But leave the spring in the barrel, take the barrel arbor out, wash that, clean the bearings, put a bit of additional thin oil on the edge of the spring to kind of work in there. But no, I can't recommend taking it out or trying to refit it by hand. Just leave it in there. Unless it's broken, of course, then you have to borrow a winder from somebody. So again, the usual chaos with tools continues. So we've got these flat nose pliers, which I have relieved both the upper side of the upper jaw to not damage the inside of the barrel, and the upper side of the lower jaw so it matches kind of the curve of the spring. So on. Gosh, it's quite a while since I've done this. I seem to be doing it every day and then not for months. He said making excuses as we go along. So yeah, if you're beginning, then leave the spring in the barrel. Watch the video I made two, in fact. One was about replacing springs, and the other one was about fitting the spring in the barrel, I think, or something. So we've got our spring hooks on there. Tricky to film and See why. We've got the old safety glasses on. With the barrel arbor, chronometer barrel arbor. Yeah. So as much as I get pilloried for doing it this way, I would say if you are experienced and for these relatively small springs, French clock springs in particular, up to this kind of size, I'm perfectly happy doing it this way. But yeah, for a beginner, go for the Ollie Baker type or the star type, which are difficult to get. It's not a good look, is it? Or the, if you can, the Bergeon one. And we're kind of building up here to buying one, at least of the Bergeon one and the Ollie Baker kind, and we'll do a kind of more thorough review. It's one of those things, again, a bit like depthing tools, that if there's anybody out there who's got a CNC engineering shop and they want to work with us to develop some better products for the market, then I'd really be happy to be part of that project. Anyway, so let's unhook that. Cool. So we've got our spring in our barrel. Now the centers opened up a little bit, probably in the process of let's just try it, because what you don't want to do is get the whole clock together, then find out the mainspring isn't hooked on, because that's a real pain. Again, we've all done that. I think that is going to, it is going to hook. I'll just get a key somewhere. I've got. So it's been like this the whole week looking for tools. It's been I think that's going to hook on there. Okay. So what I'm going to do is I'm going to lubricate the barrel arbor bearings. Can take those off now. So let's just decant a bit of our D5. It says looking for it. Oh my gosh. Right. Still haven't recovered from the live streaming either, which is great. Bit of a tool first. There we go. So just a little bit of that and a little bit of a D3. And as far as an oiler is concerned, I'm going to use just a watch oiler. You can use a bit of brass wire that's been flattened at the end and made into a kind of a spade shape. Personally, I wouldn't use the syringe type. I did get one of those maybe 20 years ago as well, and I just found it just leaked out the whole time. It's actually quite difficult to apply the right amount of oil. So let me do all the mainspring. Oh yeah, for the mainspring, sorry, somebody's just asking a question. I use the little bit of the spray grease, and there it is, that one. And for the pivots, I'm going to do those now. So for the pivots, and you could actually, you just use D5 on the mainspring, I suppose, as well. It's slow moving bearing. And you can see I didn't put much of that spray on, but there's loads there, more than enough, in fact. Don't want to over oil the mainspring, otherwise it runs out of the barrel cap, then it gets onto the great wheel teeth or the fusee line, that kind of thing. So let's dig out an oiler. This, by the way, is the brass type oiler. Can you see that there? Just made out of a bit of brass wire. They're really, really useful. kind of moved away from those a bit at the moment because they're really super useful when you're trying to get at something that's quite far inside the movement. But on the Enfield type clock, everything's pretty accessible. So there we are, Oilers, just in case you didn't know. I think that's the Badger. Yeah, that one will do. And the Oilers. So on here, these are quite sort of thirsty bearings, quite big bearings. So I'm going to put a bit on both sides. And then when the component's assembled, going to check. And that's really important, particularly if you're, well, not even if you're new, can't see. If you're new to, there we go. So quite a lot on there. New to horology, then it's dead easy to miss a bearing. So once you've got a clock on test, so barrel arbor cap on, luckily that row has died down about bashing the barrel on the bench to get the barrel cap off and then somehow whacking it to get it back on again. Well, I'm not even going to go there. I don't do no bashing or whacking if you can help it. So let's just put our jaws in. Go back here. So barrel removal, cutout, and hooking aligned is a rule of thumb. Unless there's a kind of a reason, like on a French clock, you sometimes get a file cut across the lid of the barrel and the body, the barrel cap and the body of the barrel, which is your alignment mark. If you got the spring out of the barrel, you can always test the barrel cap in different places, spinning between your fingers. Again, we show it in our excellent book. And just to check that you've got the thing, the best concentricity you can. So that's in there. Just gently work that back on. There we go. So it's back on with no drama, no whacking. It says, never leave the component like that, like I did, because inevitably it'll roll off and go on the floor. Again, we're a bit more beginner oriented today. Lots of people coming on the group and on other groups I used to look at that say, I've fixed my clock. Often they did a lot of bushing, which is like, you know, whatever, and it doesn't run now. So always check every mobile for side shake. So that's sideways free movement of the bearing at both ends. There we are. And you can see the oil there, look, just glooping about in the hole. So there's more than enough there. You must be able to see visible oil, maybe under a low power magnifying, low power glass. Another question? Yeah, that's a good question. How do you get the barrel cap off if there isn't a cutout in it? And then, of course, yeah, you have to hit the barrel arbor with a soft mallet or something, or use a puller. Might be a good idea to press on the back and push the barrel arbor cap off. Great point, and point taken. If there isn't a cutout in the barrel cap, you can't do anything else about it. Somebody really put a useful bit of information, I think it was on the Facebook group, and that was the factory service manual for those clocks. And it was really cool information there about how you deal with those barrels. And I did wonder whether they're actually, so just checking for side stick, can you see the oil? So you must be able to see liquid oil in the bearing. As I said, you often have to look through an eyeglass to see it. But if you can't see liquid oil in there when you wiggle the arbor about, there isn't enough oil there. But I would say more than enough here. In fact, on the back, there's maybe a little bit too much. Maybe I might leave it as it is. But if you've got a bit too much oil, then just wick some of it away with a piece of pithwood. Oh, camera there. Familiar with that? So this is a very absorbent plant material, and you can just draw out a little bit of oil there with the pithwood. And if you've got an oily mark on a plate where you don't want it, you can use a product called Rodico. Again, I know we all love our tools here. Bergeron Rodico, which is a kind of cleaning putty type thing. And they've just brought out, well, I don't know if just brought out this new one, which is even more expensive. And that's really handy stuff to have. So side shake, and the second absolutely critical test is end shake. So this is axial movement of the arbor within the bearing. So that's good. It's nice and loose. I actually didn't tap down some of these burrs. I know on one of these videos I did. It's not too bad, but maybe I should have done that. And again, before we proceed, we're going to find a clock key and check that the arbor hooking is hooked. Otherwise, you've got to take the whole thing apart again.
Just check the rigid parts because Rob thinks you can see them.
Tooth.
Yeah.
I had a plastic box with all the parts in for this clock. That's it. Gritty cobs, gritty cobs, gritty cobs. Ah, well done. Eagle-eyed Rob, thank you very much, has spotted a gritty cob there, look. So we're gonna flick that chap away because that is going to cause us some pain when we get the thing assembled. Clock runs fine for about 2 hours and it stops. So thank you, Rob, and your money today. Okay, we've gotten our barrel arbor back in, and as I said, I would say if you don't have a mainspring winder, then yeah, just check that the hooking's hooked. Otherwise, it's frustrating to have to take it all apart again. So let's get our clock frame and our train and get that together. Probably not going to get the whole thing done today, but it's a good start. Put that to one side. Here's our clock frame, all cleaned, pivot holes in particular. There we go. You'll be familiar with this. I noticed on this one that the click springs had a bit of mutilation, but it's still functional. And again, if you wanted to kind of straighten this up and sort of tidy it up a little bit, the only way you could really do it, and I can try with those flat nose pliers, is to get it off. But of course, it's riveted on the factory, and I don't think those little lugs would stand being undone and then folded over again. I think they'll fall off. So again, that idea of sort of compromise. Right. So here's our center arbor. On earlier clocks, you would expect to find the friction work, usually either a sort of a direct clutch like a watch on a French clock, or in the case of a long case clock, a curved spring called a bow or boat spring. But here, the friction work is actually built into the back of the great wheel. So we'll deal with that in a short while. So this pinion, which is kind of a cannon pinion, but we'll call it the brass pinion, I think, in our clock. Sometimes they crack at the back when they're pushed on in the factory. So it's worth looking out for that. So let's put that back on, center wheel and there. I'm just going to use that pithwood with a little bit of D3 on it, actually to smear the arbor with oil rather than actually like that, put on the pinion. And now we need to drive the pinion back onto the shoulder of that arbor. So we can do it a couple of ways. The way we show it in the book is by using a brass split stick here, holding it this way up and driving it down like that, with a piece of brass here to protect your pivot. What you also have to do there is to put a pin in this hole here to prevent that hole from collapsing. Now I'm going to try it a different way. And if I can, I'm going to hold this in the soft jaws of the vise and I'm going to drive the pinion on here with a piece of drilled wood, but that relies on me finding the actual tool to do it, which might be a challenge. So bear with us. Lots of, oh, here we are, hidden under a mountain of stuff. I've not tried it this way before, but I made drilled out, as you people who know me know, my favorite bit of tool is a drilled out drumstick handle. And so I drilled it out, put this bit of brass around to stop it splitting. So I'm going to hold this in the vise, pop that on there, and drive the brass pinion on the other way, which I've not done it that way before. So heck, a little adventure. Like that. Obviously, we don't want to distort our arbor, so the frame must be completely free of the vise here. But I think that's pretty much got it. Like that. And let's just try tapping it on. You have to be careful that the front plate is actually on the bearing, otherwise it can cause a big burr there. Always a challenge to know which hammer to use. So let's try it this way. Now in this case, you can hear there that it's not particularly massively tight. It went down right up to the shoulder really quite easily. That little bit of oil obviously helps a bit, so that's good. Got that on there. And let's just go back to this thing. And oh, we're running out of time. Let's just pop the train back together. Can't quite remember whether we can get the... Oh, I think we can. I think we can sneak the barrel past the center wheel from what I remember. So there's a washer that we need. Which is there, little washer, and that goes a particular way. You'll have noticed when you buy washers, because they're stamped out, they have an outside and an inside, and on these they tended, I think, to be fitted with the curved side down like that. Again, just for this bearing, it's not a working bearing per se, as in it doesn't rotate when the clock's running, but it does rotate when you're changing the time. So again, I'm just going to smear the bearing like that, pop on the wheel, pop on the center, the spring. So this is the clutch for the clock, which is quite a sturdy bit of steel. So I'm going to use my new best friend, which is my brass-lined parallel jawed pliers, just to compress the spring there. And when these clocks were new, they had an S-shaped piece of wire holding that spring on, which is a real pain to get off. So I'm not going to replace it with that. I'm going to replace it with a draw-filed taper pin, which I think is a better solution. The S-shaped bit of wire rarely, if ever, recovers from being removed. So I'm not too worried about sort of preserving that, regrettably, one might say. So I'm going to put a taper pin in there, and we will progress and finish this next week. So I've personally really enjoyed this kind of back to basics week that we've done this week. Well, hopefully that bit about drilling out arbors was useful before. This event will go on the YouTube channel later this evening, if we get our finger out, and we'll finish putting this clock together next week, because there's quite a few things I want to say about cleaning the case and that kind of order of things. And also, there's always an also, isn't there? You may remember many weeks ago now, we talked about finding a conservator to talk to us about paper labels and things. Well, I found somebody, she's super busy, but she's very keen to do this. So it won't be in the next couple of weeks or so, but I found a paper conservator who's going to talk to us about preserving paper labels. And I'm also looking for a textiles conservator who can talk to us about preserving these lovely bits of textiles in the back of clocks, because I see, again, I would say regrettably, many times, particularly in French clocks, where that original or earlier textile is replaced with a bit of pink silk or something. But anyway, each to their own. This session has really been kind of supported by our book. So if you want to learn more, then it's all in there. Thank you for buying it, people who have. Otherwise, we will see you on Facebook. Keep up the good work there. All been well, God willing, we'll be there on Thursday with the next part of our live stream, 8-day duration long case clock repair. And we'll be here again next week for the 23rd Open Clock Club. So massive thank you to Team Open Clock Club for the live chat and for all you people. Great to see you, Rob. Thank you, John, and all the regulars. Thanks very much. And new beginners, hope to see you again next week. Thank you.